Hello everyone, today in this video we are going to talk about a domestic circuit, and after this video you should be able to draw the diagram of a domestic circuit and explain the function of each component of the circuit. So before we start, I'll show you something.
Hello everyone, today I'm taking you out of my house to show you the electric post. So this is the electric post from which we get electricity. This is the wire going to my room. So this is my room, and as you can see there are two wires and many connections are taken from this pole. As you can see, one is going to that house, one more line is going to that house. So basically they are taking their line from these two wires. I'm going to my neighbor's house to show you the electric box. So this wire is coming out here, and from here it is going to the meter box. So this is a meter box which measures the energy consumed, and you can see there are some numbers and kilowatt hours. Then after that it goes to main switch. If something happens, then we can switch off this. If you pull this down, the electricity will go off, and from here it will go to the switch box. And if you switch on the switch box, and there is one plug as well. So there are two holes, as you can see. So the TV is on. From these two holes the electricity is going to the TV.
Okay, welcome back to the class. So this is the electric pole that we have seen outside, and there were two electric wires, and the name of one wire is a live wire and another one is neutral wire, and live wire is dangerous than this neutral wire. So at our houses we get a potential of 220 volt and we get the alternating current of 50 hertz. So this is the wire, and when we bring this wire to our house, to identify this wire we give color to them. The wire with red color is called live wire, and it is at the potential of 220 volt. That's why I called it a dangerous wire. And the another wire is called neutral wire or negative wire, and it is at the potential of 0 volt, and the potential difference between them is 220 volt minus 0 volt, so it is 220 volt. So this is live wire is at 220 volt and insulation is red color, and neutral wire is with black insulation, 0 potential between them is 220 volt. So now let's see the domestic circuit. So we bring two wires to our house, and first thing we'll connect it with main switch. Main switch is the switch we can pull this down to switch off the circuit of the house, and if you open this you'll see something like this, and inside there are switches. We call it Kit Kat switch, and inside the Kit Kat switch there is a thin wire called fuse wire, and the function of this wire is to protect the circuit or appliances from excessive current. So sometimes due to the fault in the connection, lot of current flows through the circuit, and if this current flows through our appliances, the appliances may get damaged. So this wire will protect the circuit from excessive current. Now let's see how it works. So fuse wire is a wire with low melting points. When the excessive current flows through the wire, it gets heated up, and if the current continues to increase, it melts with that heat and it saves the circuit from the excessive current. Fuse wire is often called a weak link in a circuit because when large current flows, it melts and breaks the circuit. Fuse wire should have high resistivity and low melting point so that it melts when excessive current flows through the circuit. The fuse wire is made from the alloy of tin and lead, and these days we don't use fuse wire. Instead of fuse wire we use MCBs, miniature circuit breaker. The problem with fuse wire is when the fuse goes off, then we have to change the wire, and changing the wire is difficult process. So if you use this MCB, so when the excessive current flows through the circuit, this switch comes down, and whenever we want the current back, we can push them up. So it is better to use MCB than fuse. So fuse comes with different ratings, meaning if the fuse is rated as 5 ampere, then this fuse will allow the current which is below 5 ampere, and when the current increases above 5 ampere, it melts and it breaks the circuit. Similarly, for 2 ampere fuse, it allows the current which is below 2 ampere. So when the current increases beyond 2 ampere, breaks the circuit. So now after main switch, we have meter box. Meter box is a device which measures the electrical energy consumed by us, and it measures energy in kilowatt hour. So you can see out here kilowatt hour is written. Then comes the distribution box, from where we give the connection to each room of our, and then we'll give 2 connection to each room. To learn how to connect the appliances to this wire, I'll take you to my workshop.
Hi everyone, welcome to my workshop. Now see, I have a bulb out here, so I want to light up this bulb. So in order to do that, I have to send a current through this. To send the current, I have to apply the potential difference across these 2 points. And from where do we get potential difference? So let me find something that gives potential difference. So let's try this panda. No, it's not giving potential difference. Now I want you to think of something that gives the potential difference to this bulb. Yeah, you can say it, I can hear you. Yes, your answer is right. The source of potential difference is live wire and neutral wire, because live wire is at 220 volt and neutral wire is at 0 volts. So potential difference between these two is 220 volts. So let's try this. Yeah, if you connect both the ends only with live wire, there will be no potential difference, because it's 220, nothing will happen. If you apply only across neutral wire, nothing will happen. So if you want to connect any appliance, you have to connect across this 2 wires, live wire and neutral wire. So let's see some examples. Now I want to charge my phone, so I'll connect it across neutral and live wire. So this is how I charge my phone. I cannot show you my phone because I'm using it right now. If you want to use a mixture, take the plug and connect it across live wire and neutral wire. So now you can see. So if you want to connect anything, you have to connect it across live wire and neutral wire.
So welcome back to the class again. So before I go further, I'd like to request the student not to try these things at your house by yourself, because the electrical wires are very dangerous. Even I got electric shock while making the circuit. So now we have understood that if you want to connect an appliance, you have to connect it across live wire and neutral wire. But I don't need to connect all the appliances throughout the day. I need to disconnect. To do that, I connect a switch, so that I can switch off when it is not required and switch on when it is required. So this switch is a device which disconnects the circuit when it is not in use. And switches are always connected with live wire, because live wire are more dangerous. So switches are connected in series in the live wire, as you can see out here. So it is in series with the red color wire, that is live wire. So if you disconnect it from here, so the live wire is not touching the bulb. So while changing the bulb, you will not get to touch the live wire. So if you connect it to the neutral wires while changing, you may touch the live wire and you get the electric shock. So the switches are always connected with live wire. So if you want to connect other appliances like fan, so you have to connect it across live wire and neutral wire, and with the live wire you have to connect a switch. So similarly for fridge, you have to connect it across live wire and neutral wire. So but there is one problem with this fridge. In many appliances we see two sockets, but the plug of fridge have three wires. One is live wire, you can see, one is neutral, and one more wire is the mystery. Now let's see what is the function of this wire. So this is a fridge, and we know the body of a fridge is made out of metal through which a current can flow easily. So sometimes what happens is, due to the fault in the insulation of wires, current may get leaked into the body of a fridge. And you know what happens when we touch the fridge this time? So current will flow to the earth through our body and we get electric shock. So to protect ourselves from this kind of electric shock, we connect a conductor across the body of the fridge and the earth. So this time when you touch the fridge, the electric current will find two paths. One is through our body and one is through the conductor. And our body has more resistance than a normal conductor, so the current will find easy path through the conductor to go to the ground. Instead of going through our body, the electric current go to the earth through the earth wire, and we don't get any electric shock. And this wire we call it earth wire because it is connected between earth and the body of the appliance. So earth wire is a wire with green insulation and which protects us from electric shock. So this is how we connect the earth wire. One end of the wire is connected to the metallic body of the appliance and another part is buried deep into the earth, and this process is called earthing. For this fridge I need an earth wire which is green in color. But at our houses we have only one common earth point for all the appliances. So from there we take the connection wherever it is required. So this wire will go to each room and each appliances in which the earth is required. If you want to connect a plug point in the circuit, then you connect one point with the live wire through a switch, one point with a neutral wire, and the third point with the live wire. So this is how we got the third wire. So third wire do not come from the electric pole, so we have to make the third wire at our houses. Now this is the circuit diagram of domestic circuit. So we have two wires, live wire and neutral wire, and it comes to main switch, meter box, distribution box, and each appliance is connected across live wire and neutral wire, and in live wire we have a switch. And the appliances which is having metallic body is connected to earth wire also, and earth wire is connected to the earth. They are lying by saying 440 volt. You should sing like लगे 220 volt छूने से तेरे.